we're going to do is talk about the definition of what is a vector. So a vector is a quantity that has length and direction. Quantity that has length and direction. And so we're going to draw a vector. So a vector has what we call an initial point. Kind of looks like a ray, but we're going to put it in a coordinate plane. So coordinate point, and then this is going to be considered our terminal point. And then we're going to label it. So we'll call the initial point A, the terminal point B. Bless you. And then the notation for it will be with what we call vector notation over the top of it. So sort of a half arrow over the top of it. Or sometimes you might see alternate notation. You might see instead of A and B, you might see vector B like that. So the notation will either be like that or like that. So that's our two ways of naming a vector. Vectors come in what we call component form. So you guys are really familiar with points in a coordinate plane, right? So if you have a point at 3, 2, you go 3 to the right and then up 2 and you put a point. Okay, so vector notation is very similar, but instead of having rounded parentheses, you're going to do pointy parentheses. Okay, so first thing we're going to do is draw a coordinate plane. And then in the coordinate plane, we're going to start right here at point C and go up to 1, 2, 3, 1, 2, 3, 4. Go up here, and we'll call that point D. So we draw in this vector here from point C, which just so happens to be at the origin. And if your initial point is at the origin, it makes it super easy to count. So you just go 1, 2, 3 to the right and up 1, 2, 3, 4. That means that this vector is at 3, 4. So instead of putting rounded parentheses, we just put pointy parentheses like that. And that's the only difference. Okay? So you're always going to start at 0, 0 unless you're told otherwise. If they don't give you a starting point, use 0, 0. But if it says your initial point is at whatever point, then it's going to move around. All right? So let's talk about magnitude. The magnitude of a vector is just going to be its length, how long it is. And in geometry, we learned that the length is always positive. You can't have something that is negative 3 inches long, or you can't have an angle that's negative 90 degrees. It's always 90 degrees, right? It's always just 3 inches, okay? So one way to think of that is just as the absolute value. So the absolute value of vector AB, or the absolute value of vector B. So example number 1, we're going to find the magnitude of vector CD, and we're going to use the distance formula. right? So we're going to say that the initial point is at 0, 0, and that the terminal point is at 2, 3. Okay, that's where our CD is at. Vector CD. So the distance formula looks like this. You can find it in your geometry book, and we've done it in a couple lessons, but it's that square root thing. So under the square root, you're going to have x2 minus x1, and then square it, plus y2 minus y1, and then square it. Notice that there are 4 places to plug in numbers. 1, 2, 3, 4. So you're going to plug in 4 numbers in those 4 spots. So you're going to use these 4 numbers, and if it helps you, label them x1 and y1, x2 and y2, so that you get them plugged in to the right spot. All right? So the first time you go to write it, just plug in everything. Plug in all your numbers, and then the step after that is where you can start to simplify and do your calculations, okay? So if it's x2 minus x1, you're going to use 2 minus 0 in the first set of parentheses, and then square it. And then it's y2 minus y1, so you're going to use 3 minus 0 in the second set of parentheses, and then square it. All right, now we can simplify. So 2 minus 0 is just 2, so we're going to have 2 squared under that radical, plus 3 minus 0, which is just 3, so 3 squared. And then simplify it some more. 2 squared is 4, 3 squared is 9, and 4 plus 9 is just the square root of 13. And so if they ask for your answer as a simplified radical, you leave it like that. If they ask for it as a decimal, you just take your calculator and punch it in the calculator, and they'll give it to you as a decimal. Okay? But if it doesn't specify either way, just leave it as a simplified radical. All right? I'm going to move this up. You'll see it in just a second here. There it is. All right, next thing we need to talk about is when your vectors are equal. So you're going to see some questions on the assignment that ask about equal vectors. In order for vectors to be equal, they need to have the same magnitude and the same direction. The other question they'll ask is if the vectors are parallel. So in order for 2 vectors to be parallel, they can have same direction, or they can have opposite direction. And their magnitudes can be different, but they need to be reducible. Different magnitudes are fine as long as they reduce to the same same fraction or whatever. Yeah, but reducible. All right. Loading that up. Sorry. All right, another thing you're going to be asked on the assignment is for something called a resultant vector. A resultant vector is just asking for the sum. What operation is the sum? Addition. So we're going to add. Yes?
What does the parentheses say?
But reducible. Okay? And so you're going to be given 2 vectors. You'll be given vector u and vector v. And all you have to do is take u and add it to v. Okay? So if vector u is at something x1, y1, and v is at something x2, y2, all you do is add the two x's together and add the two y's together. Okay, so in the notes we're showing it written out, and we'll show the step, but you're going to see that it's so easy that on your assignment you probably won't need to show the step. You can just add, right? You can do it in your head for the easy ones, and if they're really large numbers, I suppose you could use a calculator, but the two I'm about to give you are so easy. All right? So example number 1, vector u is at 3, -2. And vector v is at 5, 7. Oh, this is example 2. We already did example 1. So the resultant vector is just going to be those two added together. So we're going to say vector u plus vector v is equal to, and then we want to add the two x's together. So we're going to say 3 plus 5. And then we want to add the two y's together. So -2 plus 7. All right? Like I said, most of you can do this in your head. You won't even need to show that step. You'll just go straight to the answer, right? 3 plus 5 is what? 8. And -2 plus 7 is 5. Right? The last topic is direction. And I only point this out because you guys are pretty much only used to these kind of clocks, right? Where it just spits out the time for you. How many of you have, well, I used to have one, a dial clock. Yeah, so okay. So there's clockwise direction, and then there's counterclockwise direction. So we're going to draw a horizontal line. So just draw a dashed line and call it horizontal. So here's your horizontal line. And we're just going to pick a random point on here. So let's go right here. We'll call it point A. And from here, we'll draw a vector going out to B. And depending which way the arrow's going, so let's say the arrow's going from here to here, that's going to be counterclockwise. So you're going to see some that'll ask if they're clockwise or counterclockwise. All right?